Hello and welcome to the Gut Health Roundtable. I'm your host, Jason Prawl, and in this episode, I sit down with Krishnan, who is one of my favorite people. He's a research microbiologist and has been involved in the dietary supplement and nutrition market for the past 18 years. He comes from a strict research background, having spent several years with hands-on R&D in the fields of molecular medicine and microbiology at the University of Iowa. Kiran established a clinical research organization where he designed and conducted dozens of human clinical trials in human nutrition, and he is currently involved in 10 novel human clinical trials on probiotics and the human microbiome. In this episode, we talk about what really drives SIBO and IBS symptoms, how to protect against SIBO and IBS, the critical role of sufficient bile acid to maintain a healthy gut, and why it's so important to reduce the presence of lipopolysaccharides in the gut. Hope you guys enjoy. Kiran, thanks so much for joining us today.
Yeah. Hey, Jason. Great to be with you guys. Always great to talk gut with the roundtable. So SIBO is really interesting because you've got SIBO and IBS that kind of coalesce together, and one is representative of the other. And at the end of the day, they actually make up the most common gut dysfunctions, right? So that's what most people are going in to see a doctor about, is some version of IBS, whether it's with constipation or diarrhea. And then many of those IBSs come back as being diagnosed as SIBO. So then it's so prevalent. It's such a common condition, and it is not being resolved at all, right? So we started delving into this a little bit more and started saying, okay, we know what the symptomology is. We know what people are typically going after in terms of looking at improving these conditions. But what is the root cause of those symptomologies? What is our natural protection against those symptoms? What prevents SIBO in someone that doesn't have it versus somebody that does have it? And then if those symptomologies are a part of a root problem, then is that root problem a source of a bigger issue? Having SIBO is an issue. Having IBS is an issue. It creates a lot of lifestyle impact and quality of life impact. But having colon cancer is an even bigger issue. And, can one drive the other? Who knows, right? So we had to really dig into it to figure out what is at the fundamental root cause of this very, very common digestive issue. So we'll kind of go through that in this talk for people to kind of understand what is going wrong when it comes to SIBO and IBS, and where we see the big dysfunctions in the gut that seem to drive those symptoms, and then what are the other implications of those dysfunctions? What do we need to be paying attention to? So that's the idea behind this.
That's great. And for those of you who are new to this idea of a roundtable, this is a small select group of experts that we've hand selected really to go deep into these topics. We want to present the audience, you guys, with almost a clinical explanation, a presentation. These are talks and these are slides that are given to functional medicine doctors, that are given to allopathic doctors, to teach them about the mechanism of these things. So we wanted to skip all that and go straight to you guys. And so that's really what this roundtable is all about, getting to the source of these things and really giving you guys a great understanding of what's happening so that you can take direct action.
And, you had mentioned that these are presentations that are given to actual functional medicine doctors and so on. And in fact, I did this presentation just this past weekend in Malaysia in their largest integrative medicine conference. And then I'm doing it again this weekend coming up at another integrative medicine conference. So this is absolutely the kind of presentation we do to train doctors and give them deeper ideas into what's going on in these conditions. So you're getting it directly now from the research world. So again, this is titled Examining the Root Cause of SIBO and kind of going beyond the bloat. When you start talking about SIBO, what most people associated with it, which is small intestinal bacterial overgrowth, is that bloating, the distension that's associated with eating food. Now, IBS kind of falls into that category as well, and it's important to look at the common symptoms between IBS and SIBO. And IBS is categorized typically as IBS-C, which is constipation, or IBS-D, which is diarrhea. So people tend to have one of those two as a predominance usually. And so IBS-C and IBS-D and SIBO, they affect between 4% and 78% of irritable bowel syndrome. So 4 to 78%, number one, what really bothered me about that number is that that's an insanely big range, right? How have they not nailed that down better, right? Well, and what does it even mean? Does it mean anything when you say something is between 4 and 78% of IBS is actually caused by SIBO? What that actually means is that the symptomologies are so similar that in up to 78% of the cases, they can say definitively that SIBO is driving your IBS. But then there are cases where the predominant symptom is different enough where they're not sure. But to me, when you look at the symptomology, the most common symptoms of IBS are abdominal pain and discomfort, irregular stool form and passage, bloating and constipation, whether it's hard or lumpy stool, or in some cases diarrhea, which tends to be loose and watery. The most common symptom of SIBO is abdominal pain, discomfort, bloating, flatulence, loose motion, or constipation. Basically, when you look at the clinical symptoms of IBS and SIBO, they're essentially the same. So I would say we're probably more on that 78 or maybe even higher end of the spectrum. And why that's important is because IBS is the most common gut dysfunction that doctors are dealing with, right? And just the name IBS kind of irks me a little bit because it just says irritable bowel syndrome. It just means your gut is mad.
Right. So vague, right? There's nothing
it's
here.
So vague.
Yeah.
Totally. There's nothing here. And then they throw the word syndrome on there so it can encompass a whole bunch of different symptomologies, right? And the term, came out somewhere around 20 years ago when people were coming in constantly complaining of gut dysfunction, and doctors really didn't have a diagnosis for it. It wasn't real severe things like colon cancer or inflammatory bowel disease, Crohn's colitis. So they just named this one irritated bowels. And then now we have a closer definition of irritated bowels, which is small intestinal bacterial overgrowth. And more than likely, the vast majority of irritated bowels are due to small intestinal bacterial overgrowth. So that, I think, is an important point. And SIBO is clinically defined as an increase in bacteria in the small intestine that's equal to or greater than 10 to the 5 colony-forming units per ml of upper gut aspirate. So what does that mean? Well, the only clinical way to definitively diagnose SIBO is to do a gut aspirate, an upper GI aspirate, which means you're going into the upper GI through the mouth with a tube, and the tube is long enough to go all the way into your small intestine, and then they're pulling up aspirate, which is basically fluid, from your small intestine, and then they're going to plate it to look for the level of bacteria. 10 to the 5 colony-forming units is basically 10,000 or more colony-forming units per ml of your gut aspirate. Now, if you've got that much or higher, then they say you have SIBO, because the small intestine is actually supposed to have a relatively small amount of bacteria per ml. To compare that to the large intestine would have somewhere around 10 to the 12 CFUs, colony-forming units per ml of large intestine matter. So the large intestine has literally millions of fold higher bacteria compared to the small intestine. And small intestine, once it goes over this threshold of 10 to the 5, it means you've got SIBO. And likely it's the big driver of IBS as well. So that's important to note.
And Kiran, can I jump in here? I want to ask you, because in my experience, the people that I worked with, the people I've spoken with that think they have SIBO, none of them are actually getting this test. So it's interesting, right? That there is a clinical definition, but yet what I see in the real world is that there doesn't seem to be that many people that actually get defined this way. So I just wanted to sort of share that note.
They don't. And you're totally right. I mean, I would say the vast majority of people get diagnosed with SIBO just based on symptomology,
Right.
because nobody wants to do this test.
Right.
It's very uncomfortable and it's expensive. In fact, that's part of the thing that makes SIBO hard to study, is
Exactly.
because the definitive way of defining whether you have it or not is this invasive, expensive, uncomfortable test, and nobody wants to volunteer for it.
Right.
So we just kind of go by symptomology, which is not a great way to do a study. But this is the clinical definition, and it has to do with bacteria overgrowing in the small intestine. And keep in mind that any part of the intestine is actually an amazing, ideal place for bacteria to grow. And so, why is it that overgrowing bacteria by a small amount leads to all of these conditions? And then how do we prevent that overgrowth from happening? That's really the crux of this. And it's also important to note that stasis, that is the lack of movement in the bowel, is a widely accepted as a major feature of SIBO. And that'll become important as we go through this. Now, in my thinking about SIBO, I wanted to go through it methodically and go, okay, how do we break down this problem to really understand it? The first question we have to ask ourselves is, what is overgrowing in there? If you're at 10 to the 5, 10 to the 6, 10 to the 7, and you can be clinically diagnosed with SIBO, we need to know what those bacteria are, right? What are they? And then are these dysbiotic bacteria, meaning they shouldn't be in the small intestine and they're coming from somewhere? Or are they the native bacteria in that region that just tend to be overgrowing? And then the next question is, if they're not native, if they are dysbiotic, where are they coming from? What is the source of this bacteria? And there's all of these hypotheses out there. One of the leading SIBO doctors will tell you that it's more than likely foodborne illnesses or foodborne pathogens that comes from eating contaminated food. But then when you look at the SIBO rates, they tend to be higher than the rates of food poisoning, and so significantly higher. So I don't know if that's really a predominant source. There may be a different source to think about. And then, no matter what the bacteria is within the system, why is it overgrowing? And why is it overgrowing in some people and not in others, right? Let's assume these are not a native bacteria to the region. Then why is it that the native bacteria grow and overgrow in some people and not in others? Or if they are dysbiotic bacteria, wherever they're coming from, why is it that some people maybe get exposed to them and that they don't overgrow versus they do in certain people? And then we know that stasis is part of SIBO, and what is driving the stasis? That's a really important question to ask. And what are our natural protections against these issues, right? So the people that don't get SIBO, don't get IBS, what is within their gut that's protecting them from this overgrowth and this stasis? Those are the important questions that we wanted to ask ourselves. And the way I was looking at this is because it affects so many people of so many ages, no specific gender, no specific ethnicity, it must be a multifactorial condition, because it's not necessarily tied to one predominance. It's not tied to the presence of estrogen. It's not tied to the presence of testosterone, or it's not age specific. It's not race specific. So it must be multifactorial, and it must be factors that are driven by common behaviors. When you've got a huge diversity of people that are affected by this, and the prevalence being as high as it is, then it must be relatively common behaviors that are driving this dysfunction. If it's behaviors that are pretty rare in society that are driving it, like certain types of drug abuse or certain lifestyle choices that tend to be relatively rare, the condition should be relatively rare. But the condition is very common, so it must be driven by common behaviors. So those are the things that we thought about and we wanted to investigate. So in investigating the first part of the question is in what is overgrowing and are these dysbiotic or native microbes, we come to find that there's a good amount of information out there that gives you the clue. For example, in studying conditions that have SIBO as an established complication, and some of those conditions are non-alcoholic fatty liver disease, NAFLD, and non-alcoholic steatohepatitis, NASH, and hepatic steatosis. These are all liver dysfunctions. The following has been well understood. So these are people who are diagnosed and confirmed with SIBO through the small GI aspirate test. And then that's how they also pull samples from the small intestine to see what types of microbes tend to be predominant. What they're finding is microbes in a healthy small intestine tend to be gram-positive bacteria like Blautia and Ruminococcus. So Ruminococcus and Blautia are the predominant genuses that you tend to find in the small intestine of healthy individuals with a healthy small intestine. When you've got overgrowth, it tends to be characterized by what we call a taxa shift from gram-positive to gram-negative bacteria. Let me explain what that means. So gram-positive and gram-negative are ways of characterizing basically every bacteria in the world. They fit in one of those two categories. Gram-positive means we do something called a gram stain on the bacteria cell, and if they pick up the stain, then when you look at them under the microscope, they look really blue and purple. And the reason they pick up the stain is because they have a cell membrane, a cell wall structure, which is beyond the cell membrane. So they've got your regular cell membrane like any other bacteria cell has, but then they also have a cell wall. That cell wall is what picks up the gram stain, so that's why they look gram-positive. Gram-negative bacteria are bacteria that don't have the cell wall structure, so they don't pick up the stain, and they're called gram-negative. Now, those two bacteria, gram-positive and gram-negative bacteria, can be quite a bit different. So as it turns out, in a healthy small intestine, you've got predominantly gram-positive bacteria, whereas in an overgrown SIBO, IBS-like small intestine, you get a taxa shift towards gram-negative bacteria. Bacteria like Enterobacter ACA, E. coli, Klebsiella pneumoniae, Proteus mirabilis, and Pseudomonas aeruginosa. Now, the problem with this is all of these bacteria have pathogenic versions of them. Not all of them are necessarily pathogens, but most of these have pathogenic serotypes of these bacteria. Gram-negative bacteria are also the biggest bacteria driving leaky gut because they have a component in their cell membrane called LPS, lipopolysaccharide. So they're constantly producing this toxin in the gut that is released and then starts creating permeability issues in the intestinal lining. So just this taxa shift alone, which is characteristic of SIBO, has huge implications for overall health because now your small intestine is predominated by potentially pathogenic organisms and certainly organisms that produce endotoxins, higher levels of endotoxins. So that is problematic. Now, there are some gram-positive bacteria that are also associated with SIBO, like Staphylococcus, Streptococcus, Enterococcus faecalis, and Enterococcus faecium. These are gram-positive bacteria that tend to be associated with SIBO over the Ruminococcus and Blautia. These particular microbes also tend to be a little bit more pathogenic or pathogen dominance or toxin producing over the healthy microbes within the small intestine. So that in itself is an issue, and it helps answer the question of, are these dysbiotic bacteria or are they native microbes to the region? And as it turns out, they're likely not native bacteria to the region because naturally you should be having these types of microbes. Now, if you have IBS or you have SIBO, you've got these types of microbes that predominate the gut, the small intestine part of the gut. So then the question is, if they're not native, where are they coming from? A number of SIBO bacteria are naturally found in the colon. So that may be a source. It's been said for the longest time that one of the biggest drivers of SIBO is a dysfunctional ileocecal valve. The ileocecal valve is a valve that separates the very end of your small intestine to the very beginning of your large intestine. And remember earlier I said the large intestine has a lot more bacteria, thousands if not millions of folds more bacteria than the small intestine does. And the large intestine has fermentation going on all the time. It's supposed to happen in the large intestine and not supposed to happen in the small intestine. One of the protective mechanisms against large intestine bacteria moving up into the small intestine is this ileocecal valve. Now, the valve can become dysfunctional through inflammation and gut damage and possibly even antibiotic use and so on. So if that protective valve is damaged, then you could have colonic or large intestine bacteria moving up into the small intestine, and it could happen fairly regularly. However, that to me is more than likely a secondary route because the force that it takes for bacteria to move up back into the small intestine requires a lot more complication in the intestine. So there may be a more ready everyday source of this bacteria. So we started looking into that, and to me that there is a more sensible route for which these types of bacteria enter the system, and to me it's the mouth. Your mouth actually contains a lot of these same SIBO bacteria: E. coli, Enterobacter, Proteus, Pseudomonas, Staphylococcus, Enterococcus faecium, Enterococcus fecalis. All of these microbes are present in the human mouth. And we are constantly swallowing the bacteria that are in our mouth through swallowing our spit. It happens every minute of every day for the rest of your life, right? So you've got a constant flow of bacteria that are problematic bacteria from your oral cavity into your digestive tract, and of course your small intestine, which is the part outside of the stomach that's closest to your mouth. So the mouth could be a source of these dysfunctional bacteria. And then the question is there any evidence that there's oral associated bacteria in the gut that drives health conditions? And as it turns out, in diabetes there is. So 60% of diabetic patients, when they look at their oral microbiome, they tend to have Enterococcus fecalis and Enterococcus faecium, as opposed to only 6.6% in healthy controls. So diabetics, to begin with, have a different type of bacteria in their mouth compared to healthy controls, same age, same gender, who do not have diabetes. So there seems to be an effect in the types of bacteria that predominate your mouth and overall health outcomes. And as it turns out, a recent study found that SIBO was present in 43% of diabetic patients with chronic diarrhea, and 75% had a significant improvement in their symptoms after being treated with antibiotics. So not only is diabetes an example of oral bacteria that seem to implicate in systemic disease, but in that same condition of diabetes, SIBO is far more prevalent than in non-diabetic people. So the same Enterobacter, Enterococcus fecalis, and faecium, and some of these other gram-positive or gram-negative pathogens like Staphylococcus and Streptococcus, maybe they're playing a total role, and the big source comes from the mouth. And what's interesting is when they were treated with antibiotics, the symptom improved, which implicates a pathogen-driven condition, right? So anytime you can use an antibiotic and it alleviates symptoms, it means that killing off a particular pathogen or bacteria helps alleviate the symptom, which means that the symptom was probably driven by that particular bacteria. So this is some of the clues that it could be microbes that are growing in your oral cavity that you're swallowing every day, that's entering your system and creating dysfunction in the small intestine. And it could be driving things like IBS-C, IBS-D, SIBO, even in this case, as I've shown, diabetes. So the implications are much bigger than just the bloating and the distension of the belly. Now, the question is, why are they overgrowing, right? So why is it that some people can continuously swallow their saliva and not have overgrowth in their small intestine, whereas others do swallow their saliva and they do start to get overgrowth? Are there protective mechanisms within the digestive tract that do protect against the overgrowth? And as it turns out, there certainly are. You know, the first thing when you swallow something through your digestive tract, it has to go through the stomach. And as we know, the stomach has one of the most powerful antimicrobial protecting mechanisms, and that's stomach acid. So stomach acid is supposed to act as a barrier. We're supposed to be able to swallow our spit and all of the dysfunctional bacteria that might be in our oral cavity every minute of every single day, and our stomach acid is supposed to kill all of these bacteria. Now, if for some reason they make it past the stomach acid, there is bile. Bile in your small intestine, and the bile acid pool acts as very powerful antimicrobial, and that's concentrated in the small intestine, right? So bile is released into the small intestine by the gallbladder, and it cycles through the small intestine dozens of times every time you eat food, and so on. So bile and stomach acid play a really important role in making sure that these microbes that are entering the small intestine do not have a chance to overgrow. Bile also does one step further. It activates something called the FXR nuclear receptor. The FXR nuclear receptor is at the very end of the small intestine, and it stimulates the small intestine cells, so your own small intestinal lining, to release antimicrobial compounds. So that's how important it is for the small intestine to prevent overgrowth. The bile that is secreted into the small intestine that helps you digest and absorb fat, that helps your body sequester toxins and takes it out, also plays a very important role in causing you to release antimicrobials so that bacteria doesn't overgrow in your small intestine, right? So these are really important natural protective mechanisms. The other one is peristalsis. So the movement of the bowel itself, the contractile force continually pushing things down the bowel towards the colon and then ultimately towards defecation also is a protective mechanism, because it doesn't allow things like food and colonies of bacteria to remain in one area and putrefy. All of that stuff is supposed to be pushed out. But remember, in the case of SIBO and IBS, stasis is a very important feature of it, meaning the bowel's not moving anymore. And because it's not moving, then the bacteria and the food are allowed to stay there for long periods of time and putrefy and actually go bad in the small intestine, causing all types of symptomology. Then there's this other protective mechanism called the migrating motor complex. And the migrating motor complex is this electrical sweeping of the small intestine and the large intestine that sweeps through and kind of cleans out the surface of the inner surface of the intestines. And that sweeping mechanism has a protective effect against allowing things to stay there and putrefy and overgrow. So these are the natural protective mechanisms that we have in place that allows us to swallow our spit all day long and not get overgrowth in the small intestine, right? So if any of these things are dysfunctional, then number one, they may lead to overgrowth in the small intestine. Number two, they should be associated with SIBO. So let's look at that a little bit. First of all, the stomach acid with HCl production. What's important to note is the important hydrogen ions that are pumped out of the cell into the caniculi, which exchanges for potassium ions. That's basically how you get acid released into the lumen of the stomach. That is a magnesium-dependent system, right? This particular enzyme that does the job of the proton pump exchange actually is driven by the presence of magnesium. So if you have low levels of magnesium, if you have dysfunction in magnesium or intake, you can actually slow down the amount of stomach acid that's being produced. The other things that regulate stomach acid are histamine, which is the most significant contributor to the release of stomach acid, the production of histamine. And as we know it, lots of people are on antihistamines and also low histamine foods and so on because of histamine intolerance issues, which may be a downstream effect of what's going on here in SIBO and IBS. But then you get to a point where you're really reducing the amount of histamine produced, the amount of histamine you're exposed to, and histamine becomes the most important stimuli for the hydrogen pumps that release stomach acid into the stomach lumen. The acetylcholine from parasympathetic also has a stimulatory effect. And then gastrin, which is the one that's talked about the most with regards to stomach acid release, has the least significant contribution to the formation of stomach acid and release. So histamine and acetylcholine, and again, acetylcholine is an easy nutrient to be deficient in. Magnesium plays a very important role, a very easy nutrient to be deficient in. And then histamine, a lot of people have issues with histamine, so we dramatically reduce the exposure and consumption of histamine, but then we also utilize antihistamines quite readily, which may play a role in this dysfunction as well. Then it's important to understand bile. So bile is composed of composed of bile salts, about 0.7%, 0.2% bilirubin, and 0.5% fat. So cholesterol, fatty acids, lecithin, and so on go into making bile. What's important about bile is the facultative and anaerobic commensal bacteria in the small intestine. They can metabolize bile salts through something called deconjugation, and basically they result in the production of secondary bile salts. Now, normally 95% of the bile that's secreted is reabsorbed by the liver and then sent back out again, and about 5% is converted to secondary bile salts. So this is a really important homeostatic mechanism to understand. So what's happening here, if you look at this diagram, you've got the liver, whose job it is to produce bile. The liver secretes bile through the common hepatic duct, and bile is then stored in the gallbladder. And then the cystic duct and the common bile duct, including the sphincter, here releases bile into the duodenum when food is present. So once you start chewing, it starts activating the signal to release bile from the gallbladder into the duodenum, which is the first part of your small intestine. Then bile moves through the small intestine all the way to the end of the small intestine, the area called the ileum. And then most of the bile, 95% of the bile, is reabsorbed through the portal vein and re-enters the liver. And when it goes to the liver cleans out the bile, because remember, a good portion of this bile has picked up things like fatty acids or nutrients that are important in fat, like vitamin K2, for example. If you're getting vitamin A or vitamin E into your diet, it's picked up by bile and it's taken to the liver. And also dysfunctional things, toxins that are fat soluble are picked up by bile and taken to the liver for clearing. And so basically when bile goes back to the liver is cleaning up the bile. It is reconjugating the bile, which means kind of cleaning it up and reactivating it, and then sending it back to the gallbladder for release into the duodenum. So anytime you eat food, that single secretion of bile by the liver and the gallbladder into the small intestine can be recycled up to 15 to 17 times, right? So that's how important bile is. It keeps getting recycled through the process of digestion over several hours. It keeps going through the small intestine. As part of its job in the small intestine is it acts as an antimicrobial to dysbiotic bacteria, whereas the normal bacteria in your small intestine can actually deconjugate bile, and it does it to about 5% of the bile. So 95% gets absorbed, 5% gets deconjugated and sent into the colon as secondary bile salts. Now, why is this important? Because as it turns out, aside from activating the FXR receptor, which I talked about earlier, and increasing the antimicrobial compound production in the small intestine, secondary bile salts have been shown to inhibit C. diff. So the primary bile salt, without the deconjugation, has been shown to promote the germination of C. diff, while secondary bile salts inhibit the germination of spores of Clostridium, where it actually prevents the growth of pathogenic strains in the colon like Clostridia. So there's this beautiful harmony here where your small intestinal bacteria, or native small intestinal bacteria, understand that a small portion of the bile should be deconjugated and sent into the colon to help protect against pathogens that exist in the colon, whereas 95% of the bile then gets reabsorbed and recycled through the small intestine. All the while it's being recycled, it is killing bacteria, because bile is a strong antimicrobial itself. And then it's also reactivating this FXR receptor. So you can think of this bile cycle and the bile acid pool that continuously builds as a really important protective mechanism to detoxify the gut and then also prevent small bacterial overgrowth. So decreasing the level of bile in the gut over time, and that comes from liver damage or anything that puts the liver under stress, favors gram-negative members of the microbiome to proliferate. And remember, SIBO, IBS, there's a taxa shift towards gram-negative, and studies show that when you decrease bile acid secretion, you start to see an increase in gram-negative bacteria. Not only does that, of course, create the condition of SIBO, but it allows those bacteria to produce their potent endotoxin LPS, which can cause a whole bunch of other problems in the system, which I'll talk about in a second. So that's the importance of bile. We talked about the importance of stomach acid and some of the factors controlling stomach acid, the magnesium dependency, the histamine, the acetylcholine. There are other things that also impact the natural protective mechanism. Remember, the peristalsis and the migrating motor complex is a really important part of keeping the small intestine clean and not allowing things to sit in there for a long period of time and putrefy. Now, I was starting to look at why people's bowels would go into stasis so frequently and in such a common prevalence, and you start to see that there is a correlation between LPS and gram-negative bacteria and leakiness in the gut to the development of stasis in the bowel. So this is one study where they looked at pediatric small intestinal bacterial overgrowth in low-income countries, right? So they found that in certain low-income countries, there's a higher prevalence of pediatric SIBO, small intestinal bacterial overgrowth. They're trying to figure out why. What is the cause and the big driver of this small intestinal bacterial overgrowth in low-income countries? They concluded that it is our hypothesis that the mechanism of SIBO development in the setting of unsanitary living conditions stems from repeated exposure to abnormal levels of LPS via contaminated soil, drinking water, which then abrogates the migrating motor complex, leading to luminal stasis. So they're showing that in unsanitary conditions, you get fecal oral contamination. So you get a lot of these gram-negative bacteria from the feces, like E. coli, like Pseudomonas. They are contaminating drinking water in the soil, and these children are picking up higher levels of these bacteria, and these bacteria are entering the small intestine. Now, these bacteria also bring with them the formation of LPS, and they're showing that this LPS, this endotoxin from gram-negative bacteria, seems to be driving a dysfunction in the migrating motor complex and in the peristaltic activity as well. Then there are other studies that have shown, both in animal models and then there's some human studies as well, that E. coli-derived LPS has been shown to decrease both the frequency and strength of small intestinal contractions to eliminate to eliminate the migrating motor complex completely. So the presence of LPS by these gram-negative bacteria being released into the small intestine is a big driver of stopping the bowel and stopping the electrical signaling of the bowel itself. Now, you go deeper and you find that there are studies that have looked at this very, very specifically. So they find that induction of endogenous tumor necrosis factor, so that's TNF. TNF is one of the early immune signals for an inflammatory response against LPS, shows that it suppresses centrally stimulated gastric motility. So what does that mean? Well, systemic LPS, so if your gut is leaky and the endotoxin, the LPS from the small intestine and the large intestine is leaking into the circulatory system, what can happen is that LPS enters something called in the brainstem called the dorsal vagal complex. And the dorsal vagal complex in the brainstem is the connection between the enteric nervous system, so the gut nervous system, and the brain. Where the brain, that's the way the brain sends signals to the gut saying you need to contract now or you need to activate the migrating motor complex. What they've shown is that the elevation of TNF alpha, because of the presence of LPS, completely stops this communication. So it says, and they were not able to elicit the gastric motility response even by using prokinetics, so kinetic stimulants that are known to stimulate the nervous system of the gut to start the contractile activity so that you don't have constipation and it protects against SIBO. They weren't able to stimulate the gut when LPS acted on the brain stem. So that systemic LPS can get into the DVC, the dorsal vagal complex, and stop the signaling between the brain and the gut nervous system. So it's really quite powerful. And then these same authors did a follow-up study where they, again, induced the inhibition of gastric motility using systemic LPS. So they were injecting these animal models with LPS, which stimulated the endogenous TNF alpha production. And then when they used anti-TNF compounds, they were able to restore the release of the hormones to increase motility. So this showed that endogenous TNF alpha from LPS So the release of this inflammatory cytokine due to the presence of LPS in the circulatory system is likely acts directly within the dorsal vagal complex, leading to central motility aberration or stopping, right? So what does all this mean? The last two studies, basically they showed that when you have systemic LPS, so when the gram-negative LPS is allowed to leak through your intestines and circulate around your system, it can get to this brainstem area called the dorsal root, the dorsal vagal complex, and stop the communication between the gut and the brain. And even using prokinetics, you're not able to re-stimulate the gut. However, when they use anti-TNF compounds, so this is a compound that blocks that inflammatory signal, they were able to restart the motility of the gut, which tells you that this stopping of the motility of the gut is driven by this endotoxin LPS, and it's doing it through an inflammatory cascade, through an immune reaction in the neurons, in the dorsal vagal complex. So if you're able to stop that inflammatory response, you can restart the bowel again. So, we've got stomach acid that's supposed to protect. There's numerous reasons, and we'll talk about why people's stomach acids are dysfunctional. Then the second part is bile salts, and bile plays a significant role in preventing IBS or SIBO-like overgrowth in the gut. And then the final thing is the peristaltic activity and the migrating motor complex, and those things tend to be stopped by the presence of LPS. And how common is this endotoxemia? We know that for a SIBO to be as prevalent as it is, the drivers of SIBO have to be relatively common as well. In our endotoxemia, our LPS endotoxemia study, we found that 55% of healthy, normal college kids, meaning they don't have any chronic illness, they didn't report any SIBO, any IBS or anything, every time they ate food, they got a 6-fold increase in the amount of LPS circulating around their system, right? Which means that every time they eat food, they've got this LPS that enters in, the same LPS that causes dysfunction in the brainstem and stops the motion in the bowel. That same LPS is being elevated 7-fold every time you eat food, and that occurred in 55% of the healthy normal population that we tested. So LPS endotoxemia is really common. And as it turns out, increased fat intake can actually be a big driver of increasing the amount of endotoxemia. And we tend to see increased fat intake in SIBO because people who have SIBO tend to reduce the amount of fermentable carbohydrates that they consume because they're afraid that it's going to exacerbate the symptoms. And so they replace a lot of that carbohydrate intake with fat intake. And so fat, we know, increases LPS endotoxemia. So it might, in a way, be driving SIBO even further by increasing the fat intake. Now, the natural protective mechanism, stomach acid, some of the things that are very common that drive a dysfunction in the stomach acid are stress. We know high levels of stress tend to not only increase permeability, make LPS more prevalent in your circulatory system, but high levels of stress can also lower the amount of stomach acid secretion. We know that H. pylori overgrowth is associated with lower levels of stomach acid secretion. Zinc deficiency, magnesium deficiency can do it as well. And then probably the biggest, most common drivers are the use of PPIs, which are proton pump inhibitors, and antacids, right? So PPIs are the purple pill, all of these things for reflux and GERD that are the most common medications that are prescribed out there, and many of them are now over the counter. These PPIs are the biggest source of reducing stomach acid production. So if you reduce stomach acid production, you lose that really important initial barrier to entry of all of these microbes from your mouth going into your going into your small intestine. Now, if this is true, then there should be evidence that the use of PPIs and/or antacids is associated with SIBO somehow. And in fact, there are a number of studies that have shown this, including this one meta-analysis. And a meta-analysis is a study of a lot of studies. So they look at the authors who are experts in this field, basically review a whole bunch of studies that are on this particular subject, and then they do a kind of a conclusive, ideation around what all of the studies are showing. So what they showed is several meta-analysis and systemic reviews have reported that patients treated with PPIs, so those proton pump inhibitors, those are the purple pills and all that for reflux disease, as well as post-gastrotomy patients. So these are people that have surgically removed stomachs, have a higher frequency of small intestinal bacterial overgrowth compared to patients who lack the aforementioned conditions. And at this time, PPI-induced dysbiosis is considered a type of SIBO. So clearly, because PPIs obstruct stomach acid and PPIs are then associated with SIBO, the production and the maintenance of stomach acid is clearly important in preventing SIBO. And the way that that becomes important in preventing SIBO is not from the bacteria coming from the bottom. It's more likely protective against bacteria coming from the oral cavity, right? Because stomach acid does nothing for bacteria coming from the colon into the ileum. It only protects against bacteria coming from the oral route into the small intestine. So that is not only evidence and more than likely the dysfunctional bacteria coming in from the oral route, but then of course it's clear that stomach acid production is really important in maintaining a healthy small intestine. Here's another study that looked at increased incidence of small intestinal bacterial overgrowth during proton pump inhibitor therapy. They showed that SIBO was detected in 50% of patients using PPIs and 24.5% of patients with IBS, and only 6% of healthy control subjects. So the presence of SIBO in the regular population is at 6%, but when you look at people using proton pump inhibitors, PPIs, it's at 50%, and in almost 25% in patients with IBS. So again, IBS and SIBO very closely correlated, and of course are also associated with the use of proton pump inhibitors. They said there was a statistically significant difference between patients using PPIs and those with IBS or healthy control subjects, showing that the PPIs really have a potent impact on the risk of developing SIBO. Now, the other natural protective mechanism we talked about, which is bile secretion, and if bile secretion is compromised, then you do increase your risk of developing SIBO. Now, what are some of the things that compromise bile secretion? One of the first things is the removal of gallbladders, right? For a long time, we were just cutting them out. If they get inflamed, infected, whatever it may be, just cut them out. Well, as it turns out, they play a very, very important role in the entire digestive system. The other thing is the obstruction of bile duct itself. That obstruction can come from dysfunction in the microbiome. The bile ducts themselves have microbes that are specific in their function to keep the bile ducts open. And as it turns out, when you have dysfunction and dysbiosis in your gut, you very well can have dysbiosis in the bile ducts as well, thereby not releasing the bile that is being produced by the liver. And then, of course, liver dysfunction is the biggest driver, and dysbiosis in general can be a big problem. Now, if bile is important in preventing SIBO, and if liver function is important in preventing SIBO, then there has to be a strong correlation between liver dysfunction and the likelihood of developing SIBO. And as it turns out, there are liver disease symptoms in non-alcoholic fatty liver disease and small intestinal bacterial overgrowth. In this particular paper, they show that some studies reinforce the concept that small intestinal bacterial overgrowth plays an important role in the pathogenesis of non-alcoholic fatty liver disease through endotoxins of bacteria and tumor necrosis factor as an effective mediator. Remember those two things, endotoxins and tumor necrosis factor are the two things that are also associated early on in the slides that I showed that are associated with SIBO and dysfunction, and in particular in liver dysfunction and in peristaltic movement. So the thing that seems to shut down the peristaltic movement in the bowel is also driven and associated by liver dysfunction, right? And the presence of endotoxins. So it's all kind of tying together. So you tend to have liver dysfunction, which increases endotoxemia and the presence of tumor necrosis factor. that's associated with liver dysfunction, but that's also associated with stasis in the bowel and the bowel not moving, the peristaltic activity, and the migrating motor complex not functioning. Then there's other studies that look at non-alcoholic fatty liver disease. This one in particular looked at 372 eligible patients. 141 were tested positive for SIBO, and 231 were negative for it. That's the control group. When they looked at the people that were positive for SIBO, non-alcoholic fatty liver disease occurred in 45.4% of the study group, which were positive for SIBO, compared to only 17% in the group that's negative for SIBO. So non-alcoholic fatty liver disease is more strongly associated with having SIBO. They also showed that patients in the study group were found to have higher rates of elevated AST and ALT. Those are indications that your liver is undergoing stress and dysfunction. Of course, higher incidence rates of type 2 diabetes. We already earlier on made the correlation between those oral pathogens being present in diabetes, coming from the oral route to colonizing the small intestine, and then diabetes being associated with small intestinal bacterial overgrowth. And then they also talk about hypertension and metabolic syndrome, all of which are associated with aberrations in peristalsis, the bowels not moving, leakiness in the gut, high levels of gram-negative bacteria, liver dysfunction, and so on. So it's all kind of coming together as having certain common root causes. The other natural protective mechanisms we talked about is peristalsis and migrating motor complex. Some of the things that inhibit peristalsis and migrating motor complex are gastroparesis, celiac disease, enteropathy, which just means inflammation and damage to your gut lining, diabetes, hypochlorhydria, and LPS, hypochlorhydria and LPS as well. So all of these things play a significant role in the overall picture. So think about it this way. You've got lowering of stomach acid, and that could be from several mechanisms. The most common mechanism is the use of antacids and proton pump inhibitors, which are very, very commonly used compounds. One of them is prescription/OTC, and the other one, the antacids, are readily available on the shelf. People use them quite often. That lowering of stomach acid, lowering the production of stomach acid, increasing the pH of the stomach, allows pathogens from the oral cavity to make it past the gastric barrier and enter into the small intestine. Now, when they're in the small intestine, bile is supposed to be killing them off. But bile is dysfunctional because of liver dysfunction, which tends to be common in the Western population as well, and stress on the liver. So as the liver is stressed, it's producing less bile, and then the gallbladder dysfunction is secreting less bile into the system. This gives even more chance for these pathogens from the oral cavity to start to overgrow in the gut. Now, the moment they start overgrowing and they start releasing their LPS, one of the things that happens is that LPS gets into the circulation and goes into the dorsal vagal complex in the brainstem and stops the communication between the brain and the gut, thereby creating that stasis and that peristalsis, that stasis and that dysfunction in the migrating motor complex. That allows bacteria to stay in the small bowel longer, that allows food to stay in there longer, and allows things to putrefy more. So it's a self-perpetuating issue. And the problem is all of this makes your gut more leaky. All of this increases inflammation in the small intestine. All of this reduces the absorbability of nutrients in the small intestine. All of this can also have a significant effect on the large intestine, because one of the things that starts to occur is you start to get bacteria that produce higher levels of secondary bile salts. And secondary bile salts being secreted at higher levels into the large intestine are associated with dysbiosis in the large intestine and also the formation of inflammatory conditions in the large intestine itself. So it all comes back to, how can we increase stomach acid production? How can we reduce H. pylori, for example, is another common reason why stomach acid levels the production of stomach acid goes down, because of overgrowth of a pathogen called Helicobacter pylori. And then the use of antacids and PPIs are common as well. And then how do we, re-engage the liver? How do we get the gallbladder to secrete more bile? How do we get better bile flow going on so that we have that natural protection? And then how do we stop the dysfunction of the migrating motor complex at the very base of the brainstem. How do we undo those things? Because all of these things have huge chronic disease implications. Going beyond the bloat, the idea there is just looking at these root causes and everything else that these root causes seem to be associated with. Here, it's SIBO, and it might be the annoying bloating, and every time you eat food, you're embarrassed because your stomach bloats out too much or your gut bloats out too much. But the bigger implications here is that this is causing, these same symptomologies are causing systemic inflammation, systemic endotoxemia, dysfunction in the large intestine, dysfunction in the small intestine, all of which negates nutrient absorption, causes an increased risk for chronic disease. So there's so much more to this than just the bloating and the distension. So a comprehensive SIBO treatment would include the following. In addition to targeting the overgrowth, which is commonly done with things like antibiotics and antimicrobials, it becomes important to address the underlying issue of stasis, right, which involves LPS-mediated activation of TNF-alpha. So this central motility aberration has to be addressed, which means we have to stop LPS from entering into the circulatory system. Prokinetics in this case don't help. Like that one study showed, when LPS is in the dorsal vagal complex, prokinetics are not going to be able to kickstart the bowel to movement. And in order to stop the recurrence of SIBO, LPS endotoxemia has to be stopped and has to be addressed. The other things that need to be addressed is low stomach acid production and gastroparesis. It has to be addressed. What are the drivers of this? The two most common drivers are the use of proton pump inhibitors, antacids, and then H. pylori levels as well. And liver support is absolutely critical because we need the liver functioning appropriately to produce enough bile and then recycle the bile every time we eat. Up to 15 times it recycles the bile. Without the function of bile, we're really leaving the small intestine open for overgrowth and dysfunction. So to reduce the risk of all of the comorbidities associated with SIBO, we have to fix the mucosal damage, because over time, as you get small intestinal bacterial overgrowth and IBS, what's happening is we're getting damage to the intestinal epithelium, the mucosal surface, and the cell lines as well. And as you start getting further damage to those structures, you start increasing the risk for other conditions like inflammatory bowel disease, Crohn's, colitis, and so on. Colonic saccharolytic bacteria, so these are bacteria that take incoming carbohydrates and proteins and they convert them to really important short-chain fatty acids like butyrate, propionate, and acetate. These bacteria have to be supported to prevent further pathology and secondary complications, right? Because one of the things that people do when they have SIBO and they have the bloating and the distension is they stop eating carbohydrates, certainly starches and fermentable carbohydrates. These colonic bacteria desperately need these fermentable carbohydrates in order to be able to produce short-chain fatty acids. So we have to address this as well in terms of a comprehensive solution. So here's what we recommend for SIBO, and we actually formulated this particular product to address some of these core issues. The first thing is to stimulate bile production and increase bile flow and balance cholesterol levels. In fact, we found that in Germany, there's a prescription product on the market to improve bile secretion and bile flow, and that's the specialized artichoke leaf extract. And remember, it's so powerful, it actually has a pharmaceutical claim on reducing gastroparesis, improving gastric emptying time, and increasing bile flow. So this is a really, really important ingredient that we were able to secure for use here in the US. The other one is a licorice flavonoid. This is really important because it protects the gastric mucosa, so it increases the production of the mucosal layer in the stomach. That's what we mean by gastric mucosa. And it balances H. pylori levels. So lots of people have elevated H. pylori. That is associated with lower levels of stomach acid production. So to bring down H. pylori or balance its levels, we don't want to eliminate H. pylori, so using an antibiotic against it to try to eliminate it is not the right approach. We do want to bring their levels down so they don't affect stomach acid production. And this particular licorice flavonoid has been shown to be able to do that in clinical trials. Then the last thing is ginger root extract. Having a higher concentration ginger root, it accelerates gastric emptying, so it speeds up the movement of food through the gastric system, which is really important so it doesn't stay and putrefied. It also improves symptomology because it reduces nausea. It can bring down some of the gas and bloating. And so it's really important to kind of soothe the bowels while you're eating. So MegaGuard is our solution for while you're eating. You need this particular type of product to undo some of the damage that's being done by antacids and LPS endotoxemia, low production of bile, and so on. The other useful components would be looking at the Megaspore probiotic and Megamucosa, because the combination of these two is really important in terms of rebuilding the lining of the gut. You know, make no mistake, in the case of SIBO or IBS, there's a bunch of damage going on to the lining of the gut because the pathogenic bacteria that are allowed to overgrow tend to produce dysfunction and damage to the gut lining. So these two components will be really important to start repairing that lining of the gut. And then keep in mind, Megaspore is the only product shown with a published clinical trial to reduce LPS circulation in the blood, right? So we know that LPS circulating around the blood is a significant problem. It hurts the liver. It's associated with non-alcoholic fatty liver disease and NASH. It also gets into the dorsal vagal complex and stops the migrating motor complex and the peristaltic signals from the brain. And so it becomes really important to stop the LPS migration. And so far in clinical trials, Megaspore is the only thing that's been shown to be able to do that. Then the other thing to think about is the right prebiotic. Now, a lot of people get very scared when you start talking about prebiotics in SIBO because it seems to them that prebiotics are the big driver of SIBO symptoms because you're putting in fermentable carbohydrates into the small intestine, and those fermentable carbohydrates will start fermenting in the small intestine, causing all of the symptomology associated with SIBO. However, what we've done with the Mega Prebiotic is to actually select what we call precision prebiotics. These particular prebiotics are designed to only feed certain groups of complex colonic bacteria. So they should make it past the dysfunctional bacteria in the small intestine and actually make their way into the colonic bacteria and feed very specific groups of keystone strains. Now, why is this important? Because again, people who are having SIBO symptoms and upper GI symptoms, they typically start to eliminate carbohydrate or fermentable fibers from their diet, which means that these important colonic bacteria that make short-chain fatty acids, which are all healing in the gut, are not getting adequate substrates to make the short-chain fatty acids. So the Mega Prebiotic provides that in spades to the colonic bacteria. So that is the kind of quick and dirty talk on SIBO. But I think what is important to understand here is that SIBO, in terms of the bloating, the distension, the chronic diarrhea, the chronic constipation, the IBS-like feeling, is really a symptom of bigger problems going on within the system. And those big problems are a fundamental dysfunction in stomach acid, a fundamental dysfunction in bile production, secretion, and or recycling, a fundamental disruption in peristaltic activity in the migrating motor complex of the gut. All of these really important basic protective mechanisms are compromised, which is leading to SIBO. But the important thing to note is the compromising of those mechanisms can also lead to much bigger and more scarier problems. So it becomes important in the case of IBS and SIBO to really address these particular symptoms and root cause dysfunctions as well.
That's fantastic, Kiran. And I really want to thank you for that because, as you're going through a lot of the causal mechanisms of SIBO, there's things coming into my mind of why we're not producing enough hydrochloric acid, why we have such a high amount of LPS in our systems. And from a lifestyle perspective, right, we eat late at night, right? So we
Hmm.
know that the body has this timing, this rhythm where it's going to produce more hydrochloric acid. It's going to have better gastric motility. The migrating motor complex is going to function more efficiently during the day. And then when we
Yeah.
eat these big meals, these fatty meals, these high protein meals toward the evening, um, even if we're not taking proton pump inhibitors and all the antibiotics or anything else, we're living relatively
Yeah.
healthy. It's our lifestyle that, unfortunately, in this modern world, I mean, you and I are part of this. Even though we know
Hmm.
better, we still
Totally.
eat late at night. We still travel across
Yeah.
time zones. We still have these parties that we might go to. We live our lives in the Western world a different way than we did 300 years ago. So
Yeah.
these are the things that are naturally going to be there. And I keep thinking, Megagard, I love the label on that, because there's three simple ingredients, honestly, that
Hmm.
that are natural. And to be able to use something like Megagard as an adjunct to my typical lifestyle, where I know I'm not doing those other things to damage the gut system to reduce HCl production, but I'm still living in a way that may be lowering my natural HCl production lower than it could be.
Yeah.
So taking something like that is really, really simple way to sort of give me that added boost and give me more protection against, elevated levels of LPS, lower amounts of HCl, and a higher incidence of some of those bacterial strains in my upper GI tract. So there's
Yeah.
so much in our lifestyle.
Absolutely. And like you said, I'm guilty of that as well. I noticed that I don't have reflux. Fortunately, I don't suffer from those conditions, but every once in a while I will get reflux kind of in the middle of the night if I eat really late and go to bed right away, right? So if I'm flying into some place and I haven't eaten most of the day and I'm like, oh, I got to eat, then I eat a big meal because I'm hungry, and then I go to bed, I might be woken up at night with some reflux, and it's shocking, because it's not something that I tend to experience. So you're totally right in that, in the lifestyle aspect. And the thing about the ingredients within the MegaGuard is they really support the appropriate function of all the different aspects of the small intestine. And they have implications beyond SIBO and beyond the bloating and the reflux and so on. But we've seen it being such a game changer for people who are dealing with reflux chronically, for people who are dealing with SIBO and symptoms of IBS chronically, the people that every little thing that they put in their gut will get bloated, everything creates dysfunction and discomfort and cramping, the people with chronic reflux and GERD, this has been kind of a game changer for them. So it becomes really important to add it in. I've actually just kind of added it in with virtually every meal I take, just as a way of protecting my system. And then, as you get older, you're going to produce less digestive enzymes. You're going to produce less bile. You're going to produce less HCl. So all of those things being protected against really helps overall.
Yeah, and that's really the takeaway that I got from your presentation. And I've been looking at SIBO for a while and looking at the functional mechanisms, and some of the stuff you presented was familiar, but some of it was brand new in terms of
Yeah.
the recent research that's been out there and showing these things. And really, again, the takeaway for me is that it's such a complex system and it's all intertwined. We can't separate
Mm-hmm.
SIBO from, a leaky gut, from colitis. It's all sort of intertwined. And really, I think
Yeah.
it's just a web or a network of issues that we end up dealing with. And eventually, if it goes on long enough, they start piling up and getting worse and worse. And they
Yeah.
start showing up in new symptoms, new places, and that kind of thing. And as you pointed out, it really is happening in so many areas of our body. Obviously you mentioned
Mm-hmm.
the brain, the dorsal vagal complex. So we have the vagus nerve that's tied in. We've got HCl in the stomach. I mean, there's so much. The liver and the gallbladder plays a huge role. So there's so much going on.
Mm-hmm.
Of course, those are just a few, right? The whole system is all
Yeah.
working together. So supporting it in multiple ways, I think, is a really critical aspect. Whether or not we can definitively say I have SIBO or not, no matter what labels we put on our gastrointestinal symptoms or dysfunctions, there's so much at play. And it seems like the
Yeah.
more support that we can give with natural ingredients, with things like these supplements, as opposed to drugs that are gentle and yet effective, I think that really does seem to be the way to go for a variety of these gut health conditions.
Yeah, absolutely. And SIBO is just a version to me of normal irritated bowels, right?
Right.
So if you're somebody that every time you eat food, you get a little cramping, bloating, discomfort, and then you figure out like, oh, I can't eat these things because it causes that symptom. And then a lot of times when you talk to those people, they go, oh no, I don't have any digestive issues as long as I don't eat this, 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 and this. And you go, well, that is an issue. You're supposed to be able to eat a huge variety of things without experiencing all of that discomfort. So whether you've been officially diagnosed with SIBO, whether you have really severe reflux or constant reflux, or you just have those kind of digestive discomfort and indigestion type of issues, those are all playing around the same mechanism, and that same mechanism is also part of bigger global problems in the body. And so that's I think it's important. And I think that hopefully that message came out well. So the reason we developed MegaGuard is it becomes kind of like really basic fundamental protection against those really important systems in the upper GI, the stomach acid, the gallbladder, and the bile secretions, and the liver, and then the peristaltic activity as well, which is then helped by the megaspore and then the mucosa fixing the lining and the damage that occurs. And then finally, the prebiotic. If you've been, shortchanging your colonic bacteria of fermentable carbohydrates, you really need to get some fermentable prebiotics into your system to recover those bacteria. They play such an important role. So,
yeah. Well, and we've been carrying those three, right? On our site, we've been carrying Megaspore, the Mega Mucosa, and the Mega Prebiotic, and people get such good results from those. And that's something that we've been carrying for a while. And MegaGuard is new. It's a new development, and so we're excited to carry that as well. So we'll link to that right here on this page as an offer to everybody watching. And I'm actually excited. I think actually the name of MegaGuard is perfect because to me, again, what comes into my mind is it's a product that I can use to sort of offset some of these lifestyle mechanisms that are playing a role in some of the minor dysfunction, and so I can use it as sort of this protective guard, the shield, to help minimize the effects of a lifestyle, even though I know what I should be doing. I get pulled out of it. And so it's sort of my backup, so this is fantastic. Kiran, we love what you do. Keep doing it. It's amazing to see what you come up with next as you really get into these deep rabbit holes. And I don't want to follow you down them too deep, but I love it when you come back out with all the good info. So
they're fun.
I really appreciate
it's making sure coming out of it is really the key.
Exactly. That's why I don't want to get stuck in there. But thank you so much for presenting this to us in such a clean way. And again, we'll be linking to MegaGuard right here. And we look forward to seeing everybody on the next episode.